Okay, in this video we're going to talk about conversion factors and getting back and forth between units. And one of the more common ones that we need in amateur radio is meters and feet. As an example, we know that the start of the 40 meter band is at 70 megahertz. So we're in the 40 meter band here. And what that means is that one signal is 40 meters long. So that's a full wavelength. Wavelength is the length of one cycle. Okay, well, first we can try doing some estimating, ballparking this. I know that a yardstick is 3 feet, so that's 36 inches. And I think I remember seeing on the internet somewhere that a meter stick is somewhere around 39 inches. What I'm trying to get at is I've just made it a practice when I want a ballpark idea of what some value in meters, what it is in feet, I just multiply it by 3. So 3 times 40 is 120. And since I know the yardstick is a little shorter than a meter stick, I know that this is the low end. Okay. That 40 meters is something larger than 120 feet, but it's at least 120 feet. And this is going to be in the ballpark. All right, so that's a way of just kind of guesstimating. Let's use a conversion factor, though, and get from 40 meters to something more exact in feet. And the one conversion factor that I remember is that in 1 inch there are 2.54 centimeters, and this is a pretty accurate conversion factor. You need to be careful with conversion factors when you look them up on the internet, because sometimes they're just approximations that aren't that close. This is fairly exact in this ratio. Okay, ratios are fractions, fractions are ratios, so you are almost always dealing with fractions when you're talking about conversion factors. Okay, we're actually going to use a string of conversion factors here to get directly, or to get from meters to feet. And we want to set these conversion factors up such that, well, first of all, they're all multiplied. And that's an advantage to us because we can set them up so that this next conversion factor, I want meters on the bottom, whatever the relationship is here. Meters need to be on the bottom so that these units cancel each other out. You know, meter over meter, that's just 1. So those cancel. That's what we mean by canceling. Okay. So I want to ask the question here, can I get from meters to centimeters, since this is the one conversion factor that I know? And the answer to that is yes. 1 meter, this is centimeter, that means 100. Okay, so 100 centimeters is the same as 1 meter. So now my meters cancel out. So now I'm at least in centimeters. Now I can use the memorized conversion factor that gets me from centimeters to inches. So 1 inch is 2.54 centimeters. And these centimeters cancel out. Am I in feet yet? No, I'm not in feet, I'm in inches. So what do I know about inches and feet? Well, whatever it is I know, I need inches on the bottom so that those cancel out. So 12 inches gives me 1 foot. So now my inches cancel out and I'm left in feet. So now when I do this calculation, my answer will be in feet. So that's the next task, getting this into the calculator. How do I do that? Well, since everybody's being multiplied here and divided, I can multiply all the numerators together and then divide them by the multiplication of all the denominators. And we'll separate numerator and denominator using parentheses on the calculator, so it doesn't get confused. So let's open up a set of parentheses, and I've got 40 times 100 times 1 times 1. 1 times anything doesn't change anything, so I can close that off. That's my top. And we're going to divide it by the bottom. Again, I want to open up a set of parentheses. I've got 1 times anything, we forget that. Okay, so 2.54 times our 12 gives us 131.23 feet. All right. And let's compare that with our estimation of 120 feet. We knew that this was going to be on the low side, and it is by about 11 feet. But we're still at least in the same order of magnitude here. So this is not a bad way to just kind of, for talking purposes, estimate what our length is when we're told meters what it is in feet. All right, so what can I do with this information? Well, I want to construct a wire antenna that's a half wave. So half wave length in lambda is the Greek symbol used for wavelength typically. It's going to be this value divided by 2. So if I take my answer here, I didn't want that shifted. Yes, I did. My answer divided by 2. And I see then that this is 65.6 feet. Now, before you go out and get your wire cutters and whack off a chunk of wire at 65.6 feet, thinking you have a half-wave antenna, you're going to be close but not accurate enough. It turns out that our signal travels through wire differently than it does through a chunk of wire. So there's a different kind of a conversion going on for that. This is just a very approximate value. The actual length that we would want to cut a chunk of wire to be a half-wave antenna, it's going to be a little longer than that. They tend to be a little bit longer. It's closer to 67 feet, somewhere between 66 and 67 feet. So keep that in mind. This is just a way to ballpark the length of a half wave, or we could divide it by 4 and get quarter wave, whatever it is we need. So more conversion factors. We'll do that in a separate video where we're looking at how to get a more accurate. And even then, you want to have an antenna analyzer around when you're trimming your wire antenna, because it gets to the point where whacking off a quarter of an inch or a half an inch of the wire can be the difference between not being tuned to the frequency and being tuned to the frequency. So be careful of that. So the takeaway here basically is set up your conversion factors so that the units cancel each other out as you go down the chain, and you're finally left with the units that you wanted to convert to. And of course we could go the other way. If I was converting from feet to meters, I would be starting off with feet over here, and my conversion factor here in the middle that relates inches to centimeters, I would just turn that up the other way, be 154 over 1. So keep that in mind. Have fun.